Hello there, my name is Hugo, and welcome to Hugo's Desk. Welcome to another edition of Hugo Deconstructs. Today, I am going to deconstruct a composite for Rival Kingdoms. Rival Kingdoms was a game cinematic that I supervised about 4 or 5 months ago. This was a project made for Fire Without Smoke, which is an agency in London that I usually work a lot with, and the trailer was made. The trailer in the cinematic was made for SpaceApe, which is the game developer of Rival Kingdoms. I have to thank Fire Without Smoke and SpaceApe for the opportunity to allow me to share all this knowledge with you guys today. The point of these series is not to be a tutorial. The idea behind it is for me to deconstruct a real production shot. Sometimes we will be deconstructing composites, sometimes we will be deconstructing a CG shot, sometimes a Photoshop file. Regardless of what it is, it will always be a real production shot that I've worked on a production. So it will always be as sincere and as honest as possible because it's a real production. I should, of course, warn everyone right now on beginning this video that this is not for the lighthearted. It is a very advanced video. If you do not know a lot about compositing, it is going to be probably difficult for you to follow this video. The reason for that is because it is a very advanced composite that I will be showing today. Of course, this is not a tutorial, a normal tutorial at least, because I'm not going to be constructing the comp as you see. So on this situation, on this case today, we are going to go through the actual Nuke composite that was done for one of the shots for the Rival Kingdoms game cinematic. So I had the great pleasure of working with Stefan, the visual effects supervisor at Oxton Red Sox, and his great team of CG experts. And that's where this wonderful render comes from. Now, these renders were done basically from V-Ray. So the render engine of these renders was V-Ray, and the entire CG was created inside of Maya. The composite that you're seeing here was inside the Foundry's Nuke. Now, to start off, I must say that we've, of course, decided to use EXRs, and we decided to use multipass EXRs. And that's how we brought in all the renders into Nuke. Now, we've decided to divide, as usual, EXRs by all its passes. And because I'm quite a control freak and I really enjoy to have total control in composite, I did ask Stefan and his team to give me access to every shader and all the light passes from the CG. The reason for that is because we had a very short amount of time to do this project. This project was incredibly short. We only had about a month to create the entire thing, and so because of that, the choice was made to try to accomplish as much as we could inside compositing, and that tends to be my usual methodology. The reason for that is because not only because my background comes from 2D, but also because it just makes sense to, when you have a very, very low budget production or when you have a very fast deadline, you really don't want to have to re-render shots all the time. So by using the functionality of multipass compositing, it allowed us to basically bring all the different variables of CG into the composite. So I had access to all the light passes, I had access to the diffuse, I had access to the directional light, I had access to the undirectional light, I had access also to position passes and normal passes and Z-depth passes. But we'll get to that in a minute. Usually what happens as well is, because I want to take advantage of Nuke's multipass EXR pipeline, I tend to, first thing I do when I get a bunch of EXRs with passes is I group them all together, basically using copy nodes and using shuffles to make sure that I have every single pass inside the same stream. Now this for me is very important because when I have them all inside the stream, that means that I actually have the ability to call any different pass that I need. That means if I need a diffuse pass, or if I need a specific ID, or if I need a specific velocity pass, I have access to it. It's actually available to me because it's in the stream. And that's how we did. Basically, every render on this project was divided by 3 different renders. We had basically the beauty, which had access to all the light passes, and we had diffuse, multimatte, raw GI, raw light, and speculars. And then we had a tech pass. Now the tech pass tended to have, passes like normals, which would help us to do some relighting. It had the position pass, would help us to actually have a point cloud to help us in CG, and then of course the UV pass for retexturing and the velocity pass for motion blur. So those were the utility passes. Now the utility passes usually are separate as well, and this tends to be a way that we used to work when I used to be ahead of Nuke at the mill. We used to work this way as well. Tech passes are usually separate because they require to be rendered in 32-bit float. The reason for that is because you do want to have the maximum amount of accuracy on the passes to actually be able to use the velocity pass, the motion blur, the normals, and the position pass. Otherwise, if you render them in 16-bit, you might not have the same accuracy in terms of precision. Of course, the beauties are not rendered in 32-bit float because that is a bit of a waste of space, especially if you're doing a commercial. Maybe if you're doing a film, maybe then it's worth to do 30-bit float, but it tends to be that we don't use that. We tend to use 16-bit. And then last but not least, I had a separate pass, which was just the AOV pass, which was basically a V-Ray dirt pass. V-Ray has a lot of custom layers that allows you to make certain textures in certain custom passes. That's how we used it as well. Now, moving forward, once the passes are all gathered, the next step that we've made, and you see that I'm quite organized. So I have layer 1, which was basically my background, and then if I had another layer, I would have had more of these setups. And these setups, by the way, they're all automated. So I basically usually create them as little small Nuke scripts. I can show you that I do have in here, if you look here, I have a CG rebuild. So I have a V-Ray for multipass files, or a V-Ray with the multipass EXR with all the passes inside. So for example, if I click on multipass EXR, sorry, I should probably give me a bit of more space here. So if I put multipass EXR, you can see that it already builds a basic structure of how my composite will work. And that's how I usually tend to work. And I tend to get my freelancers to work that way as well. The reason for that is because, first of all, it's easier if everyone works the same way, of course. And then, you have more time to develop the creative side of the comps. But also, it becomes much more easy and organized to work this way, because then if you share the script with someone else, that person can immediately notice what's going on. And this is always the same methodology. I always gather all the passes I have so that it's all in the same stream, and then we move on to a stage where we actually rebuild the shader, and I'll go into that in a while, and I'll go into why I tend to work this way. And then we have, because I have a background of an editor and I have a background of color correction, I tend to work on a very structured way. So I tend to, have a global color correction, and then I have my motion blurs and depths, and then I have my, glints and glooms and glows. I tend to organize it as much as I can by stages. Almost like on color correction, you tend to have a primary color correction and then a secondary color correction. In a way, I would say that my primary color correction comes from the rebuilding of the shader. That's my primary color correction. Then my secondary color correction, which is using masks, and it's using IDs, and it's using specific masks, ramps, and rotoscopes. That is my secondary color correction. But enough about that. I'm just going to delete this really quickly and carry on deconstructing the comp. Once we rebuild all the shaders, I tend to have a CG section, which is the 3D system inside of Nuke using the position pass. We'll go into that in a second. And then from there, we usually tend to construct the shader. Now, the shader is reconstructed depending on what render engine you have. Usually the render engines are all the same. If you use, for example, V-Ray, it tends to be reconstructed on a very similar way to Arnold. But if, for example, if you use Mental Ray, it is reconstructed on a slightly different way. But it tends to be the same thing. If you have a light pass, it's a light pass. It could have different names, but it still is a light pass. And a diffuse is the same thing. A diffuse is diffuse, and a specular and a reflection and refraction. And they tend to be, 9 out of 10, it tends to be that it either will be a plus operation or it might be a multiply. It tends to be that it's a plus whenever you have beauties, and the only reason you have a multiply is if you actually are using the raw passes, the passes that are not multiplied by its own light. In this case, that's what we're doing. So I usually tend to rebuild my shader. Now, why do I rebuild my shader? I have those questions all the time on classes, and I also have those questions on keynotes. The reason I do that is because I've always worked very closely with 3D artists. I've always believed that you can't just do 2D or you can't just do 3D. You have to work together as a team, and that's always how I've been working all my career, and that's how we used to work at the mill, and how we used to work at Nexus, and how we used to work on every place I've worked before. Having that in mind, that means that if you have a 3D artist that started a process of shading, in 3D, and they've started putting some diffuses, and they started putting some reflections and some textures and certain elements and certain details on the CG, the more you can bring it into 2D, the more it's going to be for the team, because that means you have fine control and very accurate control inside compositing. Now, in compositing, things go much faster because you don't require to do re-rendering, and sometimes you can fix things quite easily just by using a roto, a ramp, or a little small soft mask. Those are things that can be fixed very easily. Rebuilding the shader means that you are actually continuing the 3D work, and also it means that you are kind of behaving like a 3D artist, because not only the 3D artist started by shading the object, but then you continue doing color correction on a shader level. That means if you want to change the light of a shot, you go into the light pass to change it. You don't just put an exposure node or put a grade or a color corrector node on top of the whole thing. You basically affect where it should have been affected, which is just the light. And I know sometimes it's hard for people to kind of leave that mindset, because tends to be that compositors also used to just putting color correctors and grades on top of everything. But by working on this way, I truly believe that it's the most efficient way and also the most creative way, because if you do want an effect in the reflections, you can do that by just affecting only the reflections. It makes sense, and it's also a continuation of what the CG artist has made. But I'm rambling now, so sorry about that. I always talk too much. Continuing over on this, what we've done here is that I had the raw GI. Once I had the raw GI, of course, the raw GI is nothing more than the raw global illumination. So that means it's not the directional light of the scene, but it's actually how the light is bouncing through the scene. What you do have to do is you have to actually bring in the diffuse pass, which is all the actual raw diffuse with no lighting whatsoever. This means that this pass only has the actual raw texture. So if you look at it, it only has whatever texture was painted in Mari or whatever texture was developed inside ZBrush, and that's what this pass has. So that means that once you have one light pass and you have the diffuse pass, what you need to do is you need to multiply them together. So if I disable all these grade nodes here, you see that once, I'm just going to gamma up so you can see it a bit better, you started with a raw pass of light, and then you had your diffuse. By multiplying together, what you basically get is you get a diffuse with the unidirectional light. That's what you get. So you basically get the GI light, so that's how it works. You multiply it down, and this is not me trying to invent how these passes should be merged. The way you're seeing it on this video is the correct technical way of merging them together. There is no other way. Compositing is mathematic. So if you are trying to merge the diffuse with the raw GI on any other way, then you're making a creative decision. What I'm showing you here is the technically correct way of making it. If you decided to do an invert or to do a plus instead of a multiply, then that's a creative decision. It's a different thing altogether. So keep that in mind when you're listening to this tutorial. As always as well, you probably noticed that whenever I rebuild a shader, I always have my shuffles, which shuffle out every single pass. And then I have an unpremult. Now the reason I have an unpremult is because I do like to unpremult all my RGBs before I do some color correction. For those of you that don't know the technique or the principles behind pre-molt and unpre-molt, then I would recommend you to visit the Foundry's website. If you go to the Foundry's official YouTube channel, you'll find the concept of pre-multiplication nuke mist busting 1. So this video is a very good video explaining the concepts of pre-multiplication. So go in and see this if you don't understand what I mean. For those of you that do understand, then you'll know what I'm trying to do here. All my passes have a certain type of pre-multiplication applied to them. Now, that pre-multiplication is usually done because there's an alpha channel involved. So what happens is that your physical pixels, or the edge of the pixels, are pre-multiplied by its alpha, or better, they are divided by an alpha channel. So again, it's all mathematics. By having a diffuse which is divided by the alpha channel, then that's why you get this kind of like fallout on the edge. Now, if I do an unpre-molt, I revert that fallout. So basically, I am revealing every single pixel of my edge, thus helping me doing color correction, because when you do color correction, you affect all the pixels, which means that if I'm doing color correction to the edge pixels, that means I am effectively changing the edge of those pixels, which means that is why when you do color correction without thinking about this, you end up having black edges or white edges. This is a very common factor that happens in After Effects, it happens in Premiere, even happens in Nuke by people that don't know what they're doing in Nuke. So keep that in mind. Whenever you want to do color correction, you want to try to do unpre multiplication. And yes, before you guys say this on the comments, I do know that the grade node has an unpre-molt function. I know that. The reason I don't use that one and I actually have a separate unpre-molt is because I like to self-contain my pre-multiplication. Because I really don't like to have to tick on every single time I do a grade node, have to go in here and tick and pre-molt RGB, and then do another grade node, and then go in have to tick again RGB alpha, because I might forget to do this. So because I don't want to forget to do it, the easiest way is to unpre-molt, do everything you have to do, and then pre-molt at the end. So once I unpre-molt this, what have I done on this GI pass? Well, I'll get back into that in a minute. I'm going to actually turn off all the color corrections so that I can show you just the raw effects that we've made. So now this is without any color corrections. So carrying on, I had my GI, which was multiplied by my diffuse. Once I've done that, what I did here as well was I had my fill diffuse, which was one of my lights, and then I had my raise diffuse, which was just basically the, the folks at Redox had. I was very lucky that they actually separated all the lights. So I had my directional rays, and then I had my rims as well, so I had control for all the rim lights that you see on the cave, and then I had the lights of the torches as well, which was separated as well, and then I had not only the lights, but I had the speculars of my rim. I had also the torch speculars, and I had my ray speculars and my fill specular. All of those, of course, because they are already lights, and they do not include the separation with diffuse, because as you can see, the diffuse is already in the light. That means that you just need to multiply them all down. So what I did here was I had my fill light, and then I multiply it with my rays. Sorry, what am I saying? Not multiplying, I mean plus. So basically, whenever you have a bunch of light passes, you basically have to plus them all together. So always keep that in mind when you have raw passes that include a raw diffuse, then you have to multiply them together to get the result. Because these light passes already have a diffuse included on them, all of them have some kind of diffuse texture, then that means that they already been multiplied by their diffuses, so you don't have to do that again. So what I am going to do though is I am going to plus them all together so that I have all my light passes in one go. So in here I have my fill diffuse plus with my ray diffuse. That gives me the two lights together, and then I'm plussing the rim, and then I'm plussing the torches, and then I'm plussing that together with whatever I had already. So that's how I usually work. I start by the GI, and then I multiply it by the diffuse. That's what that gives me, and then I apply all the lights. So these are all the lights together. And of course, they are separated because I want to have control over them, because again, like I said, I'm a control freak, so I want to control every single thing. Once you've done that, you then go into the speculars. Now the speculars or the reflections, and so same thing again, they're all plus together, same issue. So I start with my fill speculars, and then plus together my ray speculars, and then I plus together my torch speculars, and then I plus together my rim speculars, and then last but not least, I basically plus together whatever I had before. What I had before here was just the light passes with the diffuse, and now I put my specular passes. So that means that now I have my diffuse, which is my materials, all the materials of the CG, and then after that I am placing all my lights, and then after that I'm placing all my reflections. So I'm basically thinking on a shader level. That's what I want to kind of come across here. Just think like a shader level, otherwise you will never understand this. And that's it, really. That is it. I do have one extra thing here, which is the ambient occlusion pass. Now the ambient occlusion pass, if this was Arnold, it would have been applied to the GI or to the non-directional light, but I am doing a creative choice here of actually multiplying my ambient occlusion to the whole thing. The reason for that is because the ambient occlusion kind of gives you a really nice touch of giving you some smooth shadows, and gives a bit of more depth into the scenes, and that's why I tend to use it. Now that we have our skeleton comp, we started, basically we haven't achieved anything yet, if you think about it, because if you look at the original, this is the original render, and that's just the beauty. And if I look at the result, the only thing that I've achieved so far is an ambient occlusion. So that's the only thing I've achieved. So you probably think, well, that was a lot of work for nothing. Well, you're kind of missing the point, because first of all, of course, I've disabled all the grade nodes, because I will go back to them later. But the reason I've accomplished this and the reason I've made all this script this tidy is because I want to have control. And this is all about control, because you want to kind of, tweak this to make it as best as possible. Not only it's because of control, but also it's quite tidy to copy paste. And that's how we actually did this project. We tended to copy paste a lot of scripts and share them between the freelancers and share them between the team. I didn't have a large team. I usually don't work with a large team. I prefer to work for a longer time and have a smaller team, and that's what I did here. But this allowed me to give more control. But we'll go back to it later. We'll go back to the compositing, to the grade nodes later as well. Next step is to continue to do the skeleton comp. So once we've done all of this color correction and all these mergings, I finally do a pre-molt. And the reason I do a pre-molt here and the reason I have this copy node is because I tend to make a copy of my alpha channel. The reason I do this, and this usually is done on the very beginning of the script, I tend to have that copy node here. The reason I do this is I copy my alpha channel into a new original channel. The reason for this is because the alpha channels get changed by every time you do a plus. Every time I do a plus operation on every of these lights, my alpha channel gets plussed as well, which means that what happens is that you tend to forget, and you tend to end up with an alpha channel with 2, 3, 4, 5 of values, and you all know that an alpha channel should not have more than 1. That's the objective. So that's why I do a copy. And then when I finally do the pre-multiplication, that means that I'm actually doing the pre-multiplication of all my alpha channels with a complete new alpha. So this alpha is untouched and is exactly the same alpha as the original alpha that was used on the production. So that's why we would do that. We're gonna stop for now, because this video is already way too long, and we are going to continue with part 2, where I go through the rest of this script and try to deconstruct as much as I can, give you as much tips and tricks as I can out of this comp, and try to squeeze the comp as much information as possible. As always, if you have any questions, please post on the comments below. please subscribe to my channel, Hugo's Desk, on YouTube. Just hit the button. The button is just right there. It's just really right there. Just hit the button, and of course share this video with everyone else that you know that might like this video. Also follow me on Twitter at Hugo C. Guerra as well. And I will see you very soon on part 2 of this video, where I will squeeze a bit more knowledge out of this composite so I can teach you some of the techniques we've been using on our productions. Hope you've enjoyed it. I've sure enjoyed talking. I really like talking. That's always my problem. So thank you so much for watching, and I see you guys very soon. Bye bye.